Now, we are pleased to introduce our first panel of the day, titled The Infrastructure Behind AI Innovation. Moderating this discussion will be Lindsey Mastis of Blue Moves Media. Please welcome our panelists. John Roese, Global Chief Technology and Artificial Intelligence Officer at Dell. Ben Schwartz, Infrastructure Partnerships and Policy Lead at OpenAI. And Chris Sharp, Chief Technology Officer at Digital Realty.
Thank you so much for the introductions. I'm so excited to be here today. As he just mentioned, I'm Lindsey Mastis. I cover AI and technology, and I am honored to be on stage with such incredible thought leaders, and I can't wait to hear their responses. We were talking a little bit before we all came out about some of the subjects, the big subjects that are being addressed today, and they have some really incredible insights that I'm excited to share with you all. So of course, we are honored to have three distinguished industry leaders here to discuss how data center infrastructure and compute capabilities are shaping the future of AI innovation and US competitiveness in this critical domain. So we are envisioning this panel to, developing a comprehensive view of the infrastructure challenges and opportunities that are facing the US and US leadership in AI right now, from compute demands to policy solutions. I'm going to start with a lightning round question. So we're going to kind of go rapidly for this first one, and then we'll get a little bit more in depth. So panelists, please share your perspective on how infrastructure demands are evolving in your sectors and what policy measures could help maintain US competitiveness in the global AI race. Ben, let's start with you.
Sure. Well, first, thanks for having us. I say at OpenAI, we are very optimistic about the ability to build big AI infrastructure in the United States at speed. And that was demonstrated just a month ago when we announced our Stargate initiative, which is a $500 billion initiative to build gigawatt-scale data centers across the country. What do we need to do to succeed? We need to ensure that global capital, because we brought in a lot of global capital for this initiative, sees an environment where the regulations and the public-private partnerships are such that they're convinced that that building can happen on schedule and it can happen in a way that's competitive with other massive infrastructure projects around the world.
Absolutely.
Well, first of all, at Dell, we have a much broader surface area because we cover almost every aspect of connectivity and compute in the world. But to answer this question, there's two dimensions. One, on the data center side, we're also very optimistic. We don't see a demand slowdown at all, and we do see a lot of creative activities to basically work through both regulatory and technical challenges. And as you know, every cluster we're building is bigger than the last one and more innovative, and that has given us a sense of optimism about the future. Jump to the enterprise side, a different discussion. Enterprise is just beginning to start. Why that's important? That's the demand driver. We've touched maybe 1% of the enterprise processes in the world around applying AI to them. As we unlock that, that's where really the demand comes from. From a regulatory perspective, lots of different things we can do, but less is more is a good mantra. But more importantly, understand these two markets are different. Regulating the build out for the consumer market and the path to AGI is one thing. Regulating an enterprise that's trying to improve their processes is different. And so our message to regulators is don't confuse all of the different submarkets of AI into a single narrative around AI. You have to get down into the specific markets to regulate them.
And Chris.
Yeah, and just to build on that, I think from the workloads from OpenAI and then all the infrastructure coming to market, like from Dell and others, I mean, it's that broad scope. So the demand is there, and we're still very, very early ages of AI, and so we're in the augmentation era. So lots of newer types of workloads coming to market, most simplistically spoken about with inference. And so the data center, to be able to support that, is something that we're constantly looking at. And so I would say some of the things that could help us is around, and it was touched on in the earlier conversation around electrons, right? Electron production, distribution around the grids. I mean, that's some of the things that we constantly look at around the entitlements of bringing these data centers to market much, much quicker.
So let's get a little bit more in depth here. So large-scale AI models are demanding exponential increases in compute power, but the constraints to this growth, especially in terms of energy infrastructure, have been well documented. So where do you see the most significant practical bottlenecks to data center construction in 2025? And actually, Chris, let's start with you.
Yeah, so again, just drilling in on what we have to do to bring a data center to market, I think there's two elements that I think are meaningful for this audience is the overall construction of it. So the entitlements, getting the permitting, and just allowing the local communities to understand what's being brought to market. And so one of the things that we've done to differentiate the way that we view the market is a master planning concept, which sometimes looks 5 years plus on how we're going to build out these major campuses. And that campus can support, both the enterprise and the hyperscaler demand, because it's allowing both of those individuals to benefit from that construction. And then I would say the next piece is just not only the generation of the power and how you can bring that, but the modernization of the grid. And I think there's a lot of things we can do collectively to, quite frankly, think about how to create electricity in a differentiated way with some of the SMRs and some of the new capabilities that are on the horizon. The horizon of time is something that's often debated, but looking at how the electron production is going to be done and doing that in an elegant way where you can tuck it in the grid in certain scenarios, but then also modernizing that grid. So being able to do the power distribution and just working with the overall utility operators, which we spend a lot of time with, to be good customers and consumers of that power. Because one of the things that we look at is, there's a lot of concerns around what the overall demand's going to look like and if that's going to balance out or if there's any kind of pockets of demand out there. When we align with our utility operators, because of the fact that digital's been in this business for 20 years roughly, is the fact that when we work with a utility operator, they feel comfortable deploying their capital. Sometimes we offset that capital commitment with helping them build different types of infrastructure in the market, but then we actually utilize it. Because I think that's the other side of this, is you want to utilize that and be a good steward of that power in a very efficient fashion. And so that last piece of efficiency is always top of mind, not only to us, but our customers as well.
John?
Yeah, maybe two observations. One, at the highest level, we have a bit of a optics issue on data centers. For some reason, people react as if they are a bad neighbor. A data center, once you finish it, just kind of sits there. It contributes to your tax base. It doesn't add any burden to your school system. It pretty much is invisible to you. So we have to educate people about the fact that this is good infrastructure. Secondly, it drives a tremendous amount of non-technical jobs. The amount of construction workers, electricians, plumbers necessary to build one of these things is pretty significant. And so we're probably spending more money aggregate on data center build out than maybe the infrastructure bill put into infrastructure, yet we treat it differently. So we have to change the optics about it. Data center infrastructure is a good asset and it's a good part of infrastructure. The second dimension though is, the large scale data center infrastructures are having to go through those problems. As we look forward, almost every enterprise in the world will have some private infrastructure, whether it's edges or private data centers, and they're going through the same journey, but they don't have the resources and scale to navigate some of the regulatory burdens. For instance, to land a modular data center next to an existing environment in an enterprise is a pretty complex process today. It's even harder if I also want to do direct liquid cooling inside of it, which actually is a good thing because it'll be about 2.5 times more energy efficient. Yet we kind of have this counter-activity of trying to prevent the good things from happening, deploying the infrastructure where it needs to be, making it more energy efficient. And so our biggest challenge really is just education about this is good infrastructure for the long-term benefit of the country.
Ben?
So I was on the road much of the last couple of weeks looking at different sites that we're evaluating for Stargate. And at the sites, I asked the teams, looking at the timelines you're presenting, like what are the biggest concerns you have? What would slow things down? And almost universally, they said the same thing, which was first, the permitting timeline. We have to integrate all these different parts of local, state, and national authorities to get decisions on how to do the construction and when we can get it done. And the second was on equipment and the backlogs on things associated with turbines, transmission components, and various things associated with supply chain bottlenecks. So I think, just echoing what I've heard, at least at the moment, like those are the things that are top of mind.
It's almost more like logistical things. So, and Ben, let's go a little bit more in depth on Project Stargate, because it's very ambitious. It has an ambitious goal of building a vast network of AI-focused data centers. It presents a unique set of infrastructure challenges. So what are some of the most significant hurdles involved in a project of this magnitude, considering the scale, complexity, and specialized requirements of AI workloads? And also, what lessons have you learned from other large-scale infrastructure projects?
To answer that question, I think it's helpful to situate Stargate in the context of some of the large and sort of great infrastructure projects in American history. Things like the Intercontinental Railway, the electrification of the country under the Tennessee Valley Authority, the interstate highway system. In all of those examples, what was needed, and it's the same thing that's really needed at a macro level today for Stargate, is investment decisions that were focused not on the next financial quarter and public policies that weren't really focused on the next election, but on what we needed like 10, 20, 50 years in the future. And that's where you need this collaboration between the government and private capital and private industry to make those bets on the future. We see that in a lot of the sort of the tactical issues that have already been mentioned about permitting reform and getting the grid modernized and getting new types of energy capacity approved, fusion, getting nuclear plants back online, the SMRs that the senator talked about. It's sort of an all of the above requirement. But what really brings this together is that this is something of this scale, because you mentioned the size, is a question of like our political economic system and how it can compete. We are, as was noted also by the senator, we're in a competition with a different system of political economy in the Chinese Communist Party, a system that is able to aggregate tremendous resources and centralize them and then make decisions in an authoritarian top-down manner. And as a result, they can build big things very quickly. And so we need to do the same thing, not the same way, but we need to have that same effect of being able to build at scale in a strategic and long-term manner in the United States. And I think, we're sitting here in Washington, and one of the things that's encouraging, actually, in the midst of all the polarization, is that there really does seem to be bipartisan support for tackling this challenge. On the same day that the Stargate initiative was announced in the Roosevelt Room with my CEO and the CEO of some of our partner companies, the President of the United States was asked, like, what do you think of one of the Biden administration's last executive orders on data centers and the use of federal land? There's not a lot of things that President Trump has said he endorsed of a prior administration, but that he's like, that sounds like an important idea. Like, we need to do that. We need to use all the resources we have to build AI data centers at speed and scale. So we're encouraged by that.
And one of the big issues too is making sure that AI is really, you can use it all in the US without having to go to other sources, which is what brings me to a question for you, John. Sovereign AI. Sovereign AI is gaining increasing attention as a critical area of technological development. So what are the most effective practical steps governments can take to foster the growth of sovereign AI capabilities within their borders? And also, I want you to elaborate on any frameworks or models that you've developed for supporting this.
Yeah, last year this term emerged, and I think it was a bit confusing because, what is sovereign AI? Does that mean that every country in the world is going to build its own proprietary large language models? Does that mean every country in the world is going to build data centers? And the answer was, we weren't sure, but there wasn't a pattern. I ended up traveling around the world the second half of last year, talking to a lot of governments, and what came out of it was the fact that sovereign AI is very simply stating that your country must have a strategy. You must have a strategy that empowers the positive outcome of AI on your society, whatever that society is. And so one thing we concluded is there are many ways to do that. And it turns out there were effectively 3 patterns that materialized. The first was there are sovereign AI strategies which are all about building large-scale infrastructure for the purpose of governmental functions, to literally empower the government with an AI infrastructure. And there are countries around the world, our friends in China are definitely doing this, and there's other places where that investment is being made, and the result will be that their government and potentially their military and other environments will simply work better. Okay, part A. The second is what we found in other countries where the strategy wasn't government for government, it was government for industry. It was this idea that, much to the point you just made, that many industries cannot afford or do not have this capability to build out the necessary large-scale infrastructure to do the things that will actually transform their industrial base. And so investment in infrastructure for the purposes of effectively enabling your industrial base to compete by giving them the tools and resources that they otherwise couldn't actually achieve by themselves is very powerful. That's happening in the Middle East in many of the countries. It turns out that workloads running in the nationally built government data centers are not government workloads. They are things that help the industrial base move forward. And then there's a third pattern that we found in many of the countries around the world that were a little smaller, a little less infrastructure-centric, and it was really government with industry, which is this idea of saying the government plays a unique role as a convening authority to get your industrial base moving. much of the industrial base is not actually adopting these technologies. They're having trouble navigating it. They don't know who to talk to. They don't know how to build the relationships with the industry. And so we saw, definitely in Asia and some of the Asia-Pacific countries, this model being the dominant one. And they weren't building data centers. They were investing money into facilitation of pulling their industrial base together. One of the countries in Asia I met with, they have a formal program to bring their top 100 indigenous companies together in an ongoing forum and dialogue facilitated by the government in which they bring people like us in to talk to them with one goal. How do we activate the industrial base of that country and make sure that their industrial base is in the leadership position? The moral of this story is sovereign AI is the concept of you better have a strategy. You better understand how AI is going to affect your society. And this year, I think most countries will figure out what that strategy should be. But what strategy it becomes is a bit more diverse. And it does tend to fall into these three patterns. By the way, you don't have to pick one. You can pick all three. Hopefully in the United States, we do all three. In some countries, they may only do one. But the bottom line, all of them are sufficient as long as there is a strategy in which the government's role in advancing that particular society's activities around AI for a positive good is defined and present. The worst thing that could happen this year is for our government to have no strategy, because now they have choices.
Thank you. And I've got a question for you, Chris. So Digital Realty has a unique vantage point right now as one of the nation's largest data center developers. What specific bottlenecks are you seeing right now? This was brought up already in permitting, power acquisition, site selection, and also how can federal policy better align with state and local regulations to accelerate development while also maintaining the appropriate oversight?
Yeah, so I think there's a couple of elements to that just to kind of dig deeper in the overall entitlements and the entitlement process. It was touched on with NIMBYism. I think that's one of the misunderstood elements of a lot of the communities of what the benefits of the data center and the benefits that it brings to that broader community. So we constantly work against people not really understanding the true value of bringing a facility online. I think some of the other elements of it that I think is very near and dear to our hearts in this group is electron production, and not just from traditional sources, but new sources, and just ensuring that that's consistent and aligned with the overall demand within the market. And so we're constantly working with different types of solutions, from the traditional utility operators all the way through, cutting edge new SMR providers as well. And it's that type of balance that's absolutely required. And I think, just to walk through a little bit more detail in the amount of supply chain required to bring a facility online is pretty monumental. And so we're always working and sourcing from multiple suppliers all throughout the world just to ensure that we can meet our customer demands. And then it's another element that's often overlooked is the overall construction and the talent of people coming in, doing the electrical, doing the traditional, even plumbing. Because I think one of the things that most people haven't connected the dots yet is a lot of these AI data centers require a tremendous amount of plumbing, and it's not your traditional plumbing. Right? It's much more technical, these technical loops and bringing liquid to the individual racks and into the facility. That takes a lot of talent that we're constantly sourcing and training and ensuring that we work with the right providers, construction teams, so that we have that talent, not just here locally, but all throughout North America and even the globe. And I think that's a shortage that's not been understood yet today. Then continuing forward with the local oversight, I think there's a lot of permitting that's local permitting that I think may be a bit of an overreach, because once you get a kind of standard steady state and an understanding of how these facilities are going to be brought online, I think there's a lot of work that could be done to streamline that process. So once it's been defined and designed and been operating, there should be a way to go much quicker with the same type of build, just in maybe a different market, a different locale, that we could expedite that as well. Because I think one of the other elements of this demand is time. Time to market, time to opportunity, time to turn up. And the piece that we push on, and it's less about government oversight or anything like that, but standards. There aren't very many standards inside of AI, and unfortunately, the integration point of all of this cutting-edge technology is the data center. And there are very limited to no standards on flows, taps, and everything required to make this AI performant in our environments. And that's one of the things we're working and continually ideating with our partners, and just to demystify that for our ultimate customers, such as OpenAI and some of these workloads coming to market, because things like that have to happen for us to find efficiency factors to hit the overall demand, because there's not enough electrons, there's not enough data centers out there today, so efficiencies have to be found throughout that process, and we're constantly ideating and innovating with our customer base today.
And also the summit is covering the networking side of AI infrastructure build out, not just compute. So Chris, in your mind, what are the most important innovations in cooling, networking, and power management that can support those AI advancements? And I know you're touching on that right now.
You know, I love it. I'll echo John's point. Like, liquid is a good thing. There's a big efficiency step function because of the ability for liquid to dissipate the thermal energy being placed into these data centers much, much more efficiently than air. We're pretty excited about that. So the overall flops to watts scenario of how much power you're getting to how much compute you get will have a major step function. I think, you know, the networking piece is something that, you know, I've written many blogs, and you know, about 6-7 months ago, we wrote a blog around a private AI exchange. So for whatever we've seen, and just to demystify a lot of this, the AI in the most broadest sense will mature like we saw with the clouds. Right? So when we had early cloud adoption, it was being done over transit or over the internet, and there was no private access to a lot of this infrastructure. There isn't an AI environment where you don't need some type of broader data set that's not residing within the four walls of the data center. And so the concept that we've always been pushing is an optical exchange that has extremely high throughput associated with it to be able to allow customers to intercommunicate and leverage each other's capabilities, be it a GPU array, be it a new data set, whatever it may be. Really allowing a very simplistic, secure fashion for that to interoperate is one of the things that we're constantly looking at and ideating with our customers to build that private AI exchange. So that connectivity is definitely top of mind. And I think the last piece on the designs, the densities associated with, so it's not just about total capacity block, it's about the density you're able to support within the facility as well. Because you want to put this compute as close as possible to overcome some of the challenges with the liquid and liquid cooling, but also the cabling. It's 10x the cabling price. So the further you distribute this infrastructure because you can't support the density, the cost in cabling steps up rather tremendously. And so being able to do a design that allows for, you know, 150, 200, 300 kilowatt designs is something that we've been working throughout I've been there almost 10 years, very modular designs where we can support an enterprise customer where it's 8 kilowatts, not very dense, but then all the way up to a hyperscale or a larger AI-specific compute where it can get to the 200 kilowatt, 300 kilowatt rack density. So that versatility is absolutely a requirement as you start to see this infrastructure come to market.
Thank you. And John, let's talk about governments in the priority for sovereign AI capabilities. What specific technical and operational requirements should they consider when it comes to the data center strategies, and also how do these requirements differ from traditional enterprise data centers?
Yeah, you know, if you think about the role of government in the AI ecosystem, yeah, there's internal uses that are maybe in a vacuum, but for the most part, they're the convening authority. They're in the center of a very big ecosystem. And so, you know, comments you just made, the ability to interwork. You know, when we think about AI, one thing that's very clear in terms of the technology as we move into things like agentic is the value of an AI system is not in isolation. You know, Bob Metcalfe once said, the value of the network is equal to the square of the connected users. You know, the more users you have in a system, the more valuable it becomes. Well, in this case, the users aren't in a single system. Agents talk to each other over distance. They interact as APIs. And so the government has to think about their architectures a little differently than a single enterprise. They may be a place where hundreds or thousands or hundreds of thousands or millions of entities interact in an AI experience. And because of that, their network has to be different. They have to be more open. They have to be significantly more standardized. And they have to realize that they are a place where trust relationships are going to be managed. So security and controls are going to be important, but not at the expense of openness and the ability to enable the outcome. So their role is just different. They're a convening authority. They're a central node in an ecosystem and a fractal. And because of that, they're going to have to think about their technology a bit different than a single bank or a single tech company and how we would build our infrastructure.
And Ben, I've got another question for you, and this is kind of going back on some of your experience, your prior experience. So your experience spans both public service at the CHIPS office and now the private sector. So what are some of the most eye-opening things that you have observed regarding AI infrastructure development and deployment since you've transitioned from the government to industry?
I think I would identify three things. The first is just the speed of technological development in the AI infrastructure space. In my last job, we looked at a lot of semiconductor companies' business plans and their projections of demand because we were trying to evaluate supply chain resiliency. And And like what we're seeing today just blows away a lot of the projections that I was reading in my prior job. Just this past week, CSIS put out a report in which they said, last year there was about 5.5 million GPU H100 equivalents in US data centers. And they projected that by 2030, there could be 86 to 159 million GPU demand requirements. And even if that projection is like vastly inflated, even if it's just a fraction of that, you're still seeing this just colossal growth in demand. So that's sort of the first thing that surprised me. The second is the need to plan for a future that is in some ways just hugely different than the present. I spend a fair amount of time like reading history, like nonfiction. My wife reads fiction, I do the nonfiction. And I feel like I need the transition to like sci-fi reading, because we have to sort of make investment decisions and plans based on totally new ways of integrating this technology. So that is the second surprise. And the third is what I sort of mentioned before, which is actually there's like bipartisan focus on this, like a lot. It's clearly this administration with their sort of energy dominance council and their AI czar and the focus on compute, like they're totally aware of the consequences of this kind of technological development, and people are trying to figure out like how to position ourselves to compete effectively. So, those are the three things that hit me in this particular job.
All right. Well, now I really want to ask about like your favorite sci-fi novel. Okay, that's a question for later. I want to get to what I like to call our final lightning round here. Very quick responses, and this is where you get to give advice, which we all love. Now, the current administration has shown a great deal of interest so far in prioritizing U.S. AI leadership. So the question is, what advice would you give the administration as they build out national policy to ensure that the U.S. maintains its lead? And John, why don't we start with you? You look like you're ready.
Sure. I have two jobs. I'm the CTO of the company and the chief AI officer, so I'm my own customer. As the chief AI officer, I have to navigate 700 global regulatory authorities that are imposing rules on me without talking to each other. So the first advice is less is more. Regulation is fine, but having 700 distinct regulatory frameworks is untenable, and it means I have to stay away from certain areas because it's just impossible to navigate. Good news, lots of low-hanging fruit, lots of things to do. When I run out of low-hanging fruit, it's going to get harder. So number one, less is more. Number two is, if you're going to regulate AI, do not oversimplify it. It is not a single market. There is a market that is pursuing AGI and ASI and consumer in the future of search. There is a market that is pursuing productivity in enterprises in the industrial base. There are even markets that are pursuing traditional AI around machine learning and computer vision. These are not the same thing. The technologies are similar. Do not regulate them as if they are one entity. Get involved, understand the industry structure, and regulate the industry as it exists, not in some abstract concept of AI. And then lastly, regulate the intent, not the technology. We saw in Europe, and in other places where if you try to specify technology, by the time you put the regulation out, the technology isn't even the same. And so it is incredibly important to focus on the intent. Do you want privacy? Do you want controls? Do you want safety? Those are fine, but do not specify the technology necessary to do that because you will never keep up.
Chris.
Yeah, I would echo a sentiment around thinking through the infrastructure required for the outcome. I think a lot of people want outcomes and they have anticipation of understanding the demand. There's a lot of infrastructure that has to come to market. And so simplifying some of the entitlements, some of the works that we have to do throughout different markets and ensuring that that return and that balanced kind of approach is there, I think is absolutely paramount for, as you had said earlier, agentic AI or some of the reasoning and some of the complex models that are coming to market. We're still very early days and doing a lot of training where inference is tucked into training. I would invite everybody to go very slow around how much inference it's going to require for the broader markets, both enterprise, hyperscale, all of the monetization of AI. The amount of infrastructure required to support that is pretty monumental. So making sure that you think through all of the infrastructure required and those investments in a timely fashion to keep us at the forefront of this, I would invite you to just think through all of the elements required and associated with that.
All right, Ben.
So it's been noted, just the scale and size of these investments requires a tremendous amount of capital. And so I think what the government should focus on, and we're in actually a place where there's a lot of people with a financial background in this particular administration, is to use the authorities of the government to provide reassurance to that capital that there's going to be a return profile that manages the risk. So that's doing everything from facilitating timelines to get things built quickly, to providing offtake agreements that provide the U.S. government compute over time, to using the financial authorities resident in the U.S. government to just create a level playing field, because you have other governments that are using all of those tools to advantage their own industries and to try to make it very attractive for capital to flow into those countries.
This is all incredible advice. I want everyone to thank our panelists for coming in this morning. A lot of really great insight here. And of course, your expertise in AI infrastructure scaling, enterprise computing solutions, data center operations, it's invaluable as we work to strengthen Americans' position in the global AI race through robust digital infrastructure development. Again, thank you so much.